Alright. In this question, it is asked us to find out the conditions under which the interference of light, the intensity, radiation intensity is maximum. Now, it's given to us that a system which consists of two coherent point sources, 1 and 2. Let's list the point sources. Let's say this is point source 1 and this is point source 2. They are located in a certain plane so that their dipole moments are oriented at right angles to that plane. Alright, and the sources are separated by a distance d. So the distance between the sources is, let's say, d. Now the source 2, this is the source 2 which lags in phase behind the source 1 by phi. This is the source 1 and this is source 2. Source 2 lags by a phase pi behind source 1, and then we have to find out the angles theta at which the radiation intensity is maximum. Now theta is the angle which is made by the line joining these two. Let's say this is the midpoint between the sources. So, and this is some point P at which we need to find out the intensity. If the intensity is maximum, then we need to find out what is this angle theta. So let's construct this diagram first. Alright, so this is the distance between the two sources. This is source 1, this is source 2, this is the distance between two sources. Let's call this as d, and this is the angle theta which we need to find out such that at point P we get the maximum intensity. Now this is the path traveled by the wave from source 1, and this is the path traveled by the wave from source 2. Let's say this distance is d and this angle is theta, so this will be equal to d cos theta. Now, in reaching at point P, this source 2 has traveled a distance equal to d cos theta more than the point source, the wave from point source 1. Thus, we can say this wave which is reaching at point P lags due to this path difference that is extra covered. Now, coming to the solution, if we need to find out what is the if the intensity received here is maximum or not, we will need to find out the interference is constructive or not. So for the condition of constructive interference, we know that the net phase difference at this point, the total phase difference at this point P between the two waves should be of the form 2n pi. So we say for maximum intensity at P, the net phase difference between them should be equal to 2n pi. So the net phase difference can be calculated. This source 2 already lags from source 1 by a phase of phase of phi. So we can say that phi plus, due to this path difference, this point source 2 is again lagging by a phase difference of 2 pi by lambda into d cos theta. This should be equal to 2n pi, where n is any integer, that is 0, 1, 2, 0 plus minus 1 and so on. So we can say from here that d cos theta is equal to 2n pi plus minus phi 2n pi minus phi into lambda by 2 pi. So if we divide this whole equation by 2 pi, we get d cos theta is equal to n minus phi by 2 pi into lambda. So this is the condition. This is from here we can find out what theta is. So theta is cos inverse of n minus phi by 2 pi into lambda by d, where n equal to 0 plus minus 1 plus minus 2 plus minus 3 and so on. So that is the angle theta where we get the maximum intensity. Now the next part of the question, it states that we need to find out the conditions under which for any angle theta, this theta equal to pi, the intensity is maximum, and in the opposite direction, that is theta equal to 0, it is minimum. So for maximum intensity at P, we again have that delta phi should be equal to 2n pi, which gives us this relation again, d cos theta equal to n minus phi by 2 pi into lambda, which we already calculated. That is d cos theta should be equal to n minus phi by 2 pi into lambda. Now that is the condition. Now it is given that for theta equal to pi, it should be maximum. So for theta equal to pi, using theta equal to pi in this condition, we know that cos theta for theta equal to pi will be minus 1. So minus d equal to n minus phi by 2 pi into lambda. That is what is the condition. Now again, for minimum intensity at P, from minimum intensity at P, we have delta phi should be equal to 2m. Let's say there's some other quantity. Let's call it as 2m plus 1 into pi by 2. Right. This is some other quantity. That is 2n plus 1 into pi by 2. That should be, or we can also call this as 2n plus 1 into pi. Alright. So delta phi is that. So we can use this for to calculate again similarly from here. That is phi plus 2 pi by lambda into d cos theta should be equal to 2m plus 1 into pi by 2. This gives us the relation that d cos theta is equal to m minus phi by 2 pi plus 1 by 2 into lambda. Now it is given to us that the intensity should be minimum in the opposite direction, that is for theta equal to 0. For theta equal to 0, this will come out to be d equal to m minus phi by 2 pi plus 1 by 2 into lambda. Now this is the first equation, let's say. This is the second equation. These are the two conditions under which they should be the given situation is possible. But now we need to find out the conditions on n and m. So if we add 1 and 2, then we should get that n plus m plus 1 by 2 minus phi by pi. This should be equal to 0. This is adding equation 1 plus 2. Now you can see into lambda. Now you can see that this whole equation equals to 0 if and only if this is possible, if n equal to minus m and phi should be equal to pi by 2. Then only this equation is possible. So if n equal to minus m and phi equal to pi by 2, then this situation is possible. That is, we can say that minus d equal to, as you can see from here, from our previous question, that previous solution that we did, that is minus d should be equal to n minus phi by 2 pi into lambda. So using phi equal to pi by 2, and n equal to minus m, we can get the relation, that is n minus phi equal to pi by 2, that will be equal to 1 by 4 into lambda. So D comes out to be 1 by 4 minus n into lambda. Now, since n is an integer, n should be less than or equal to 0. That is, n should be equal to 0, minus 1, minus 2, minus 3, and so on. So that is the condition. That is, n is equal to 0, minus 1, minus 2, minus 3, and so on, and phi equal to pi by 2. This since phi is less than pi. So phi equal to pi by 2 are the conditions under which the situation is possible. Thank you.